Good morning, my dear students. Today I'll teach you here the energy of the chapter number 2. But some of the students asked me that what are the difference between torque and the couple. Okay, so that is the moment of a force and the couple. What is the difference? So what I said, in case of the torque, here the force is acting on a body at any point, not in the center of the mass. Torque means the force into the perpendicular distance from where we applied the force. So here I am applying the force, that means I have to increase this force like in this way. And these force of the lines, what is the distance of this force of lines from the center of the mass? This distance we have to consider. So let it be OA. So it is OA. It is known as the torque, and here only one force acting. Okay, and remember here it is also being rotated, but if the fixed point or the pivot is not there, that time what happens in the body, here in case of the torque, the body can rotate as well as it can be moving through a linear motions. Okay, it can be moved through a linear motions. But here in case of the couple, what happened? The force is acting, here, equal force is acting. Let it be F, then there is also another force is acting F. But here the force is not acting here in a same point. Okay, the force not acting here the same point, and also not acting here to that pivot. Okay, so here in case of the couple, both of the forces same but in equal in direction. Now in that case, if there is no fixed point, that time then also it will be rotate. It's not go for the translatory motion. Okay, that is the difference point. And whenever we calculate the couple, we have to take the force and the distance from its pivot point. So main difference here, only one force acting, both of the force acting, similar magnitudes, opposite in directions. Okay, here not mentioned that what is the magnitude of that thing. Here if the pivot is not there, then the object can rotate as well as go for a translatory motion. Here in case of the couple, both same force, opposite direction, and if the pivot point or the fixed point is not there, that times also it can rotate, only it can rotate, not go for the translatory motion. Remember, couple is a special case of the torque. Okay, couple is a special case of the torque. So that's it. Now come to the main point, that energy, as we are discussing in the second chapter. Okay, so what are the energy? So energy means the capacity to do work. The capacity of doing work is known as the energy. Okay, that means I am doing work, so for how long I can do the work, my capacity. So this one is known as the energy. So whatever be the unit of the work, that is the same unit for the work, as the work is being a scalar quantity, so energy is also being a scalar quantity. Okay, but in case of the sum of the unit is being different. For example, here whenever in case of the we are calculating heat energy, that time we will not use the joule. We will use the joule, but here in case of the heat energy usually measure in case of the calorie. Okay, when we are discussing the heat energy, we calculate the energy in case of the calorie. Another thing here, whenever we are calculating the energy of an atomic particle, that times we will discuss in electron volt. The energy of an atomic particle is in electron volt. What is the relation between the electron volt and the joule? Remember, 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. This is the relation between the electron volt and joule. So energy, what is energy? Energy is the capacity to doing work. Whatever be the unit of the work, that is the same unit of the energy, but some of that unit is being little different. What are the different? In case of the heat energy, we calculate in the form of calorie. In case of the atomic energy, we calculate in the form of EV, means electron volt. 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. This value you have to remember for the numericals. Now here, difference between the energy and the power. Energy, as we know, as I discussed, the capacity of the doing work. Power means rate of doing work. Energy, here you can see there is no time Okay, there is time term is fully here absent, no requires any time. But in case of the power, time is required. SI unit of the energy, joule, and SI unit of the power is watt. That is the difference. Now I am solving in one numericals from the Telenar page number 29, question number 8. So just look that numerical. Question number 8. A pump is used to lift 500 kg of a water. That means mass is mentioned 500 kg of a water from a depth of 80 meter. That means height is mentioned 80 meter and time is also mentioned. What is given? 10 seconds. Okay. So you can see it's kg meter. So both are in the SI unit. So no need to change any unit. The first question is that the work done by that pump. So work done here equal to mgh. M is mentioned 500. G value is given. Yes, G value is given 10 meter per second square. G is also given 10 meter per second square. That is into 10 and H is mentioned it's here. That is 80. Okay, what is the unit of that? Here the work done unit is being that joule, as you all know. So joule. So that is multiply it 5, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 joule. That means 4 into 10 to the power 5 joule. Okay, that one, the first ones. Next one means saying the power at which the work. So what is the power? Next one, power is a all know the rate of doing work T. That means 4 into 10 to the power 5 by 10. Unit of power watt. That means 4 into 10 to the power 4 watt. If you want to convert into kilowatt, we have to divide it by 10 to the power 3. That means it is 40 kilowatt divided by 10 to the power 3 means 10 to the power 4 by 10 to the power 3, that means only 10. So 4 into 10, that is 40 kilowatt. Next one is efficiency, and if efficiency is mentioned 40%. Power rating we have to find out. Power rating, whenever we discuss that next chapter, that efficiency, what is efficiency, then we will fully learn what is efficiency. But here some hints is mentioned. What is efficiency? Efficiency means useful power by the power input. Efficiency is written in the form, efficiency is written as eta. Efficiency is mentioned as a term eta. This symbol is known as eta, equal to here what output by that what input. That means here is mentioned power. So power output by the power input. This efficiency is mentioned 40%. 40% means 40 by 100. And power outputs, as you already calculate, that 40 kilowatt, that is 40 by P input. So just input equal to 100. Okay, 100, and as you calculate in the kilowatt, so it is also being kilowatt. So just check the answer. Yes, 100 kilowatt. So in this way we can solve. So try to solve the other numericals. That's it for the day. Thank you.